In this video, I'll thoroughly discuss and solve the first variant of your mid-exam for Quantitative Reasoning 1. Here in this video, I'll try to give you detailed and clear explanation to help you tackle the problems. So here the first question is, x plus 3 plus iota y minus 2 is equal to 5 plus iota 2. Find the values of x and y. Now you need to find the values of x and y variable. And if we look over here, it is very clear that here we have the real part, and here this is because here we have in multiplication outside the bracket iota. So when we will multiply inside the bracket, it is easily understandable that this is an imaginary part on the left hand side, and here we have the real part and here we have the imaginary part. In order to find x and y variable, we need to equate real parts from both sides of the equation, and similarly in order to find the imaginary part y, we need to equate imaginary part on each of the sides. So let's do that. First of all, we will try to find the real part, that is x. Actually we need to find the x here, and here y will be the imaginary part. So here x plus 3 is equal to 5, because here on the right hand side we know that what is the real part. So now we can solve easily this equation for the variable x. We need to subtract 3 on both sides of the equation, and we will left with the x equal to 2 here. Now for the imaginary, for the y value of y variable, we need to equate the imaginary parts on each of the side of the equation. So we will have imaginary part y minus 2, that is equal to iota 2. So it doesn't matter that if we write this iota on each side or not, because eventually it will be cancelled out from each side. So we will left with the same equation. And now we need to solve this equation for the variable y. We will shift that 2 to the right hand side, and for that we need to add this 2 on each side of the equation. This will be cancelled out and we will left with the y equal to 4. Now this is the solution of this equation here. Now we solved this equation, this question, for the variable x and y. And now what will be the right option here? You can check it. This one is the correct option. So, and now if you are not given the options here, how you can figure out that either you have solved the problem correctly or not, to check that is this is the solution of this question or not, or this equation or not, we need to substitute these values back into the equation. So we have the equation x plus 3 plus iota y minus 2 equal to 5 plus iota 2. Now we will substitute here x as a 2 and y we have 4. So right hand side will be as it is. We will write as it is that. And now from here you can see that we have this 5 plus iota. Now here what we have, that is 4 minus 2, that would be 2. So here you can see that left hand side is the same as right hand side. So this means we have solved this problem correctly, even if you are not given here options. So you can verify, you can check your solution either it is correct or not. Now the next question is, what is additive identity in a real number? Below you are given 4 options. The additive identity is a fundamental concept in mathematics, particularly in the field of algebra. The additive identity is the a number that when added to any other number leaves the number unchanged. It doesn't affect on the number when we add to the any of the number along with this. In the context of the real number, the additive identity is represented by the number 0. So how we can understand it? For instance, if we take any particular number, real number a, not particular number but any arbitrary number, let's say a, we say that a belongs to real number. So when what is the number here, what kind of number here, and we will get a result a itself. What will be that number which will not affect on it, which will leaves it as it is? So what is that number? Definitely that is a number 0. So it will leave it as it is, it will not affect on it, and we will get back the number itself same. So now we have taken this a is any arbitrary number, it can be any number. For instance, if we take particular number, let's say a is 1. So what is a number here which we add to number 1, so it will give us the number itself? So that is a 0. Similarly, you can take any other example, let's say -3. So here again, what is a number which we add to number -3? It will return us a same number -3. So definitely that would be a 0. So in all cases, this is our identity number, additive identity. So in real number, in general, 0 is the additive identity, because whenever we add 0 to any of the number, it returns the same number. It doesn't affect on that number, it leaves the number unchanged. We need to find the domain of 1 upon square root of x minus 3. Now we are given few options as well. Now first of all, we need to understand that what kind of function this is. This is actually a rational function, and in general we can write it in the form of p of x divided by q of x, where q of x is not equal to 0, because whenever denominator is 0, it will become an undefined function. We know that 1 upon infinity will give us 1 upon 0 will give us infinity. So here, that's why here it is a condition on q of x. And what are these p and q? These are the polynomial functions. And now here we have this kind of function, rational function. And here one thing is very clear, that this denominator should not be equal to 0. This means the square root of x minus 3 cannot be 0. Now the another thing is it that we need to find the domain of this function, and there is another thing. What do we mean by domain? Domain is each input value where we substitute in the function, it will returns us a definite number which lie on the real line. It will give us a defined number. It would be not infinity and nor imaginary number. So we need to keep in mind that whenever we have the square root function, because we know that here in this function, this rational function, denominator is a square root function, and in square root function we know that we cannot take a negative number. If we will take a negative number, it will returns imaginary number. So how we can find out that this here, whatever this, for the square root of x minus 3 function, we know that it should be strictly greater than or equal to 0 to be defined. It will give us a defined value when it will be a greater than or equal to 0. Equal to 0, it will not affect, but yes, when we will take this kind of function x minus 3, here what we need to take, that we will not take this equality, it should be greater than 0. Here we cannot take this equality over here because of this denominator. Now we have the rational function where q of x is not equal to 0. But in this case, if we consider only this kind of function which is in the denominator, here we can take equality over here. So now here you can see that how we can find the values of x here. So we can take the square on both sides and we will left with this number. And now we can solve this inequality. And in the previous lectures I have discussed already how we can solve the inequality, how we can shift this negative 3 to the other side. So I will not do that here. It will give you greater than equal to 3. And now we can say that for this kind of function, if we have a function like this, square root function, but it is a rational function. So here for this we can write this could be a domain. But now our actual question is rational function 1 upon x minus 3, and for this we know that in the denominator we have, now this function is now in the numerator, but now here it is in the denominator. We cannot take this equality over here. It would be a strictly greater than 0. So for the domain of this function we can say that would be strictly greater than 3. And in the interval form, how we can write the domain of this function, because we have this function in the question, so we will consider this one, not this one. But I think in the other variant you have this kind of question as well. So if whenever you will have this kind of situation, this kind of problem, you can consider this is the domain of that function. And in this variant, because we have this rational function, so domain will be x strictly greater than 3. And now in interval form, how we can write it, x is greater than 3, so lower bound will be 3 and the upper bound could be any number till infinity. So we will take this would be the right option. So here we can see that where is that, so this D. D would be the right option. In fourth problem, we are given absolute value inequality, and in order to solve that, we will use the property of absolute inequality in interval, and we will after the solution we will determine the right option given over here. So here we will use the property absolute of x is greater than a if and only if x is less than strictly a or x is greater than a. So we will use this property, and now this time here you can see that here we have x is this whole expression, so we will take that. Instead of x we will write over here 2x plus 3 will be greater than number 5. A is here in this particular question 5, and if and only if now 2x plus x will be 2x plus 3 greater than a, or 2x plus 3 less than negative 5. Here will be also 5. So now we have to solve this inequality, both of the inequalities. Now we isolated this inequality separately, and now we solve both of them individually. So first of all we will take this one, 2x plus 3 strictly greater than 5, and it will give us here how we can solve this inequality, as many of inequalities we had already solved. So 2x plus 3 negative 5, we will shift that to the other side and we will left with this. And now again we need to remove this 2, it will be cancelled out, and we will get here this solution. And now we have another inequality, 2x plus 3 less than negative 5, and similarly on the same line we can shift this 3 to the other side. So from there we will get, here it will be 3, so negative 8. And now again we need to remove this 2, so we will get here negative 4. So now we have these both are the solution of this inequality over here. And in interval form we can write it like from here we can say that that is greater than 1. So 1 is our lower bound, and till infinity, or now x is less than negative 4. This means this 4 is upper bound and this will be infinity, negative infinity. So this is the solution, and we can say that both are the solution, so we can write in the union these solutions. So this would be the right option. So now we can check the right option. What was that? Here. So this one would be the right option. Now the last one, question 5th. Dua bought a sweater for 1000 euro and later on sold it for 10,000 euro. By what percent did the value of sweater increase? So this is a problem of percentage increase, and we need to find the percentage increase in the value of sweater. So we can write the formula for that. Percentage increase is equal to actual increase upon original value. Multiply by 100. So that would be now what would be this actual increase? Actual increase is equal to new value, that is 10,000. So you can say that what would be actual increase? New value minus original. Value. So that would be a actual increase. So we can say that that would be 10,000 minus 1,000. That will give you actually 900. So that will give you 900. 9,000. So in this way we can say that what is the actual increase? That is 9,000. And what is the original value? That was 1,000. Multiply by 100. We can cancel out these and simplify it, that we will left with 9 multiplied by 100. So that will give us actually 900. So this would be a right option. That would be a right option for that one. 900%. So class, here I have solved and discussed the first variant and the section A of your mid exam. So on the same line you can solve the rest of variants on your own, but still if you want me to solve the rest of variants, let me know in the comments. Thank you.